photovoltaic effect has been known since the early 1800s, and we're only recently harnessing that to generate electricity. The early solar cells were very inefficient. Even now, they're not. I mean, there are limits to how efficient they can be. But early solar cells were very inefficient and were more just to demonstrate the photovoltaic effect. And it's only recently that they have become a practical means of generating electric current. Semiconductors have really spurred the growth of solar panels and photovoltaic cells. Practical solar cells started to be developed and were used, have been used very extensively on spacecraft, and are now being used quite a bit more on Earth to generate our electricity, either for for mobile things that need electricity, or even we're starting to see them be incorporated into stationary power plants. Solar cells can be electrically connected into arrays called solar panels, and then the panels can be combined into even larger arrays. Tesla has done a lot of work, for example, in creating these enormous solar arrays. A small array might power a calculator, or a larger one might power a house. Again, these are becoming more common, that not super rapidly, but people are more often putting solar panels on the roofs of their houses. The largest arrays can actually function as power stations. As I said, Tesla is known for doing a lot of experimentation with uh, solar power, both on homes and in electric power stations. In certain conditions, solar arrays can allow sites to use electrical energy without a connection to an electric grid. They can generate their own electricity and not rely then on the burning of fossil fuels at some central location. If you're going to power your home, let's say, with solar panels, then it is super helpful to have batteries that store that electricity, so you can gather electricity during the day and use it all night. Or you can gather it when it's sunny uh, and use it then when the weather is not as cooperative. Solar panels and batteries can provide electricity without depending on the electric grid. The electric grid is the whole system that is connected to an electric generator. So the usually includes a fossil fuel burning plant, or possibly a nuclear plant. In areas with frequent power failures, as we've seen uh, become issues in the news recently, those happen because there's too much demand. Like in California, we have power outages sometimes during the summer because so many people are running air conditioning. Or storms may take down power lines. Or then solar panels and batteries can sometimes provide a more reliable source of power because the sun is always there. Some medicines and vaccines must be kept in a narrow temperature range, which is difficult to do in remote areas. Maybe in areas of the world where there isn't a reliable power grid, solar panels are a more valuable and more reliable source of electricity. So, an increased availability of electric power from solar panels would mean that these medicines and vaccines could be stored more reliably. And so there has been an increased interest in recent years in solar power. But just like with fossil fuels, we see, in any other kind of fuel, we see a lot of geopolitical issues caused by the fact that solar panels are the materials to make solar panels are available in only certain parts of the world, and the manufacturing of solar panels is done only in certain parts of the world. So this is contributing to changes in power dynamics, international, global power dynamics. And so there are issues associated with, even though solar power sounds great, there are environmental impacts to generating the solar panels and disposing of them. And there are also these international issues that kind of have to be considered, that go beyond just the science and the physics.